Now we're going to look at scientific notation. Scientific notation, it's always going to be a positive number written in the form where A is greater than or equal to 1 but less than 10. So that means you always have a single digit here. Times 10 raised to the n, where n is an integer, which means it can be positive or negative. Now converting from scientific to decimal notation, they want us to write each number in decimal. So this right here tells me that this is a very big number. 10 to the 7th, that's 10 times 10 times 10, 7 times. So I know it's a big number. But because our number system is based on 10, it's a matter of me moving my decimal from here in the positive direction, because this is a big positive number, 7 spaces. So going around the 6 is 1, but I've got to add 6 more zeros. So that would be that number. So when you have a positive exponent, then you're going to have a large positive number. Your calculator will show these, but not in this form. Actually, it will have something that looks like this, where it's telling you the A value and that this is an exponent that goes with your 10. This one, a negative exponent. See, these tell you the direction you have to go and how many spaces. If it's positive, you go to your right. If it's negative, you go to your left. So going this way, going around 1 is 1. So I need 3 more zeros in front. So let me put my decimal. 1, 2, 3, 1. So you see that is from here going to here. I've got 4 digits. A negative exponent just means you've got a very, very small number. Now going from decimal notation to scientific, we've got to move the decimal, which is here, back to here. Now since this is a big positive number, my exponent's going to be positive. So I've got 4.6. Remember, this number has got to be between 1 and 10. Not, well, actually 1 and 9. Times 10. Now how many places did I go to move this decimal? 1, 2, 3, 4, 5, 6. So that would be 4.6 times 10 to the 6th. Small decimal. This is going to be a negative exponent, but I've got to move that decimal from there to right here. So that would be 2.3 times 10, and I have to go 1, 2, 3, 4, 5 spaces. And if you rewrite this, that tells you the direction you have to move your decimal in scientific form and how many spaces you have to go. Now, of course, because these are exponents, our rules still exist. In multiplication, you multiply your values, and then you work with your bases that are raised to the powers. So if you've got multiplication, you use your product rule. If you have division, you use your quotient rule. If you have base raised to power, you distribute that all the way through. Now, after you do the computation, the answer may need to be adjusted before it can be expressed in scientific notation. So let's look at these problems. These are going to be some examples of that situations in the box there. So 4 times 2 would give me 8 times 10 to the 5th times 10 to the 9th. So that would be my multiplication rule up here. That means I have to add my exponents. Now that one is completed because it's in the correct scientific notation form. No decimals, no fractions are allowed in scientific notation. So you need to divide 1.2 by 4.8 and see if you come up with 0.25 times 10 to the 6th. This has got to move up. Remember, it's a negative exponent. So I've got 0.25 times 10 to the 9th. Now this is not in correct form. I have to rewrite this. So first worry about this. Since this is a decimal, I'm going to have a little negative exponent with this. and I only have to move one space. Hopefully that one's okay. So now let's distribute. So I'm going to have 5 to the third times 10 to the negative 12. Well, 5 to the third is 125. Let me put that right here. So if I change that, that'd be 1.25 times, since this is a large positive number, I'm going to have positive exponents. So because I have to go decimals here, got to move it here. So that becomes 1.25 times 10 to the second times 10 to the negative 12. So my answer on this would be 10 to the negative 10. One more problem. National debt. As of December 2006, the national debt was 8.6 trillion, or 8.6 times 10 to the 12th. Right? Yep. At that time, the U.S. population was approximately 300 million, or 3 times 10 to the 8th. If the national debt was evenly divided among every individual, including little tiny peoples, in the United States, how much would each citizen have to pay? So I've got to divide. So 8.6 times 10 to the 12th divided by 3 times 10 to the 8th. So you need to go and divide 8.6 by 3. And let me get my calculator. So we'll round it to, what do you want to, 2.87? We could do that. Usually I indicate how much you have to round it to. I didn't in this problem. Times 10, I've got to subtract. But now if I really want to see money-wise what this is, I've got to take this from scientific notation back to decimal. And since that's big positive, I take it that way 4 spaces. I guess, though, if we wanted to be exact, and we move it 4 spaces, so 1, 2, 3, 4. So actually it would be $28,666.67. And I'm sure a 2-year-old could pay that. But anyway, that's using, and sometimes you see this in the newspaper where they have scientific notation, because just think how you'd have to write that out. A lot of zeros there. So that's it. So do these problems and let's see how you do.